So we need to find the volume of the solid generated by revolving the region bounded by y equals x and y equals the square root of x. To do this, first we'll need to graph. So first we'll have to graph y equals x. And then we'll also graph y equals the square root of x. So what we need to do is revolve this around the x-axis and find the solid that it forms. So it's easier to get a better idea of what you're doing when you just draw the whole figure out. So the outside is going to come around like this since you're revolving around the x-axis. And then we care about the point that they intersect. They intersect because of the interval from here to here. So here's like about the base of it. It kind of looks like that. And then to find the inside, I'm just gonna from here to there. So looking at this, we sort of like you have this truffle thing, I don't know, like circle thing, and you're carving out this inside. So you're really only looking for this little spot here, revolving around it, the one from the volume of just this spot, this piece. So to find the volume of this, you basically just take the volume of this whole thing subtracted by the volume of just the inside cone, and then you'll find the volume of this. So to think about the volume of the outer shape, we can use the disk method. And the radius is always this. So you make a disk. And the radius is always the function of which it's touching, so it's halfway, so it's from here to here. So the radius is always going to be this. So this is the radius, and then the depth, it's going to have a depth of dx. So the volume of this entire disk is going to be the depth of the disk, dx, times pi. And then you take this times the radius. And the radius is always the distance from the outer function. So from here to here, it's always going to be the square root of whatever this is. So the radius, so with this problem, we would do the radius squared. And the radius squared is the square root of x. So if we just wanted to find the volume of this outer, we would just take a sum of a bunch of these disks. So an easier way to do that, or basically the same thing as the integral of this. Now we need to find the boundaries, which is also where the two graphs intersect. So just like in algebra, we would set the two equations equal to find the intersection points. So you could set x equal to the square root of x. The easiest way to do this would be to get it to be factorable. So you would square both sides, squared, so x squared equals, and now the square root of x squared is really just x. So you should take x squared, set it equal to 0, minus x equals 0, factor out an x. So you'd get x minus 1 equals 0. So x equals 0 and x equals 1. So what intersects that? 0 and 1. So the boundaries of the integral was from 0 to 1. So all of this would be the volume of the outside. However, now we need to also find the volume of the inside to subtract them. So we would subtract the integral of the inside, which is also going to be from 0 to 1. So let's think about that. We need to construct a disk on the inside. So we'll do from here, and now the radius of this is going to be y equals x. And then it will also have a depth of dx. So for this we have dx times pi times, it's always r squared for the area, and the radius is x, so it's x squared. So a general way to do this, easier way than two separate ones, same thing though, is 0 to 1, and then we'd have to bring pi out, just basically just to combine the two. So we have x squared. If the square root of x squared is really x, because the square root squared is just regular, and then dx subtract, because we already took the pi out here, the x squared dx. So really, you could also generalize it again, is pi 0 to 1 x minus x squared dx. Now to integrate, we still have the pi out front. We have the pi out front. And then integrate, so the integration or the antiderivative of x would be x squared divided by 2 minus x to the third divided by 3, and then you're taking all of this from 0 to 1. So we have pi again, and then you have 1. You plug in a 1 for all the x's, so 1 squared divided by 2 minus 1 to the third divided by 3, which really equals pi times 1/2 minus 1/3, which is pi. Now you have to subtract that from, plug in a 0 for everything, so we'd have pi times 0 squared divided by 2 is 0, and a 0 to the third divided by 3 is also 0, so the answer is just pi over 6. So we were able to find from all of this that pi over 6 is the area of this little kind of gutted out thing, which is this part and this part, revolving around this axis. So that volume, not area I said earlier, the volume would be pi over 6.